is minimum cost to convert a string second. So you are given two zero index string source and target, both of length and consist of lowercase English characters. You are also given two zero index string arrays, original and changed, and an integer array cost, where cost of I represent the cost of converting the string original to the changed one. Okay, so we have given this source and the target. We have to convert source to the target and then calculate the minimum cost according to this original and change. So in the first part of this question we only have the characters to be changed, but in this question we are also we can get the strings, direct string to convert. So first let's get the shortest means minimum cost from going from each node to another. So let's first make use of Floyd-Walsall algorithm to calculate the distance from each node to every node, the minimum distance from each node to every node. So first let's take the infinity value from the math module. So math dot infinity, import math. Now simply we can take the length of the source and is equal to length of source. Now we need the unique nodes for our graph, so we can simply take the set of original and the changed one. So this will give us the unique nodes for our graph. So now we can simply create a dictionary which will contain the key value pairs s and I, the index of the string in this string list. So simply we can create that for I comma s in enumerate strings. Now we have created this idx. Now simply take the number of nodes, how many number of nodes will be there, m is equal to len of idx. M is equal to len of idx. Now let's define the distance. So distance is equal to infinity. Distance is equal to infinity for I in range. We have to create 2D one. So infinity for I in range m, then for I in range m. Now distance of each string from the same string will be 0, so we can mark that. So simply for I in range m, distance of I will be equal to 0. Now we have calculated this distance. Now make use of this original change and the cost array to get the minimum cost from changing from one string to another. So for original comma change comma weight in zip of original comma changed comma cost. So distance of idx of o to idx of changed is equal to minimum of distance of idx of o and idx of changed and this given cost. So we have calculated this minimum distance. Now we will be using the Floyd-Walsall algorithm to calculate the shortest form from each node to every node. So simply for k in range m, for I in range m, and for j in range m, we can simply calculate distance at I, distance at j is equal to minimum of distance at I, distance at j comma distance from I to k distance of k to j distance of, so by using this float Walser algorithm we have calculated the shorter distance from each node to every node, now we will calculate, and now we will have to find the sub arrays in this source string. So for that we can simply use the try. So let's create a try class. So try node class try node. So define init self, so self dot children is equal to, this will contain the children of that particular node, and self dot ends, this will contain the words which are ending, okay, the complete words. Yeah, so now we can simply get the root for this. So root is equal to try node as defined above. Simply now we can simply go to original. So for o in, we will insert all the values. So for o in originals, let's put node is equal to root currently, and then for character in o, new node will be node is equal to node dot children dot set default what to set the character comma try node. So this set default, if there are already a children of this character, then it will return that node value to us. Otherwise it will set the new node value to this try node, create a default try node, and return this empty try node to us. And at last we can simply node dot in ends, we can append this complete string original, so that we know where this word ends. Now we can simply create transactions to keep all the transaction records. So we can create a default date of list. So default date is not imported, we need to import that. So from collections import default date. Yeah, so now we have imported this, trans is equal to default date. Now we will simply go to all the source nodes. So for I in range n is nothing but the length of the source node, we'll set node is equal to root and j is equal to I. So we will be traversing in the reverse order of the dp from n to 0. So here we will simply traverse while j is less than n, and source of j is there in the nodes dot children, node dot children. So we can simply set node is equal to, we can go deeper. So node is equal to node dot children of that source of j. We will go till the last, till where we are each character in matching. Now we will simply increase the j value, j plus is equal to 1, and now simply go if for o in node dot ends, or originally nodes are where it will serve which are the complete words. So we can simply set, take the length l is equal to len of o, we can take the length is equal to, and if this I plus l, this index, if this I plus n index is less than or equal to the n, so we can simply calculate the target subarray is equal to target of from I to I plus l, and yeah, we have got our target subarray. Now simply, if this target subarray is in our idx dictionary which we have defined above, this idx, if it is there, means we have got our target. So simply if t sub in idx. So what will be the distance? D is equal to nothing but the distance at idx of original to, from idx of original to idx of t substitute or t sub array. Okay, and now if this t is less than infinity, you define infinity as cap. So infinity, we can simply append that value. So trans of I dot append, we can simply append the index value comma the distance itself. So now our transaction dictionary is completed of list. Now we can simply create a dp. So dp is equal to infinity for I in range source, for I in range gain of source plus 1 and plus 1. Yeah, so dp is and now we will set the dp of the last n value to 0. We are following top down approach here. dp of n is equal to 0. Now simply traverse the loop. So for I in range n minus 1 to minus 1 from minus 1, and if source of I is equal to target of I. If source of I is equal to target of I, means both are same, there will be no increase in cost. So dp of I will be same as dp of I plus 1. Else if it is not same, we can simply get the value from our trans. So for j comma z in trans of I, we have calculated above this trans dictionary. From j comma z in trans of I, dp of I is equal to minimum of dp of I comma this value c. C is nothing but this distance here, so c plus dp of, we have got the j value, j is nothing but this I plus l, so dp of j. And finally we should return our answer, return -1 if dp of 0 is still, dp of 0 is still is equal to infinity, else we can return dp of 0. So I think the code is completed. Let's try to run this. Okay, syntax error for, oh what for, I have written 0 here instead of 4. It is this one. Yeah, let's try to run now. Name strings, typo mistakes, strings. Now try to run. Yeah.